Hi guys, we're going to go over some mixtures and solutions vocabulary and just get us ready for your next mixtures and solutions lab. Okay, if you want to pause the video at any time and get these vocabulary definitions onto your vocabulary foldables, please do so. That should be a fairly easy process for you. So I'm going to start with a saturated solution. That's just a solution that has as much solute as possible dissolved in it. Solubility is really just the ability or property of something to dissolve in a solvent. So such as you can say how soluble salt is in water. You would say it's highly soluble or mildly soluble, right? It might have low solubility. That's kind of how you talk about solubility. And it's just, can you put a whole bunch of stuff in it and have it dissolve or not? Okay. Solute is simply the substance that dissolves in order to form the solution. Solvent, okay, is, the substance that dissolves in a solution to form a solution. So the solute is the thing that does the dissolving, gets dissolved like salt, and the solvent is what it will dissolve in, typically the liquid. Remember, water's the universal solvent. Okay, and then last thing for you is crystal. Okay, a crystal is just a solid form of a material. You can identify it by its natural shape or pattern. It's got a very geometric shape and pattern. Okay, on to our lab. We're doing mixtures and solutions lab 2, and we're going to be separating a salt solution, because last time you were able to separate the gravel and the diatomaceous earth basically by filtering was the concept. You used a screen to filter out the gravel and the coffee filter to filter out the diatomaceous earth. Unfortunately, we weren't able to separate the salt. So we're going to ask a couple of questions. First, we want to make sure that that salt doesn't disappear. It just doesn't vanish. And so we're going to ask about the weight of it. Does it weigh more, less, or equal to just water on its own? And we're going to use 50 milliliters as a kind of our staple measure. And in our class, we use 5 milliliter scoops as kind of also a staple measure. So watch for those. So you guys just create a hypothesis. You'll just need to decide, fill that in. Either it does or it doesn't weigh more. Will or won't. Or it could be equal. So the words that you could fill in your hypotheses would be more, less, or equal. Okay, one of those words would probably fit best in there. Okay, so now what we're actually asking is, how do we actually separate it? How can we actually go about getting that separated out? I don't know, you decide. What would you do? If you had anything possible in the world to separate it, what would you do? If my line is not big enough, you write as much as you want to, okay? But come up with a way to separate it. You can talk to your table group tomorrow about it. Okay, so what we're going to do is we'll use a syringe and a stir stick and a balance scale, some cups, some weights, some trays, our sticky note that we are going to label with, and our evaporation discs. And you're actually going to make the solution, okay? And we're going to add 50 milliliters of water. We're going to balance the balance scale. I will go over that in class. And we'll add salt to the empty cup. And we'll use the syringe. We'll make sure the salt dissolves, and we will weigh all of that. We want to make sure that as we weigh it, we're being very careful to record that information. So I'll show you what that looks like, and we'll subtract the larger number from the smaller number. You'll have a data chart that looks something like this. Okay, so that will be lab 2. Our goal is to end up with a separated salt solution.